Hello everyone, welcome back to my channel. Always remember your teacher Maestro Neo. To start with, let us recall the definition of quadratic equation. What is a quadratic equation? A quadratic equation is a second degree equation, or it is an equation in the form of ax squared plus bx plus c equals 0, wherein the value of a, the value of b, and the value of c are all real number, and the value of a is not equal to 0. Why? Because if the value of a becomes 0, then the equations are said to be linear equation. Ax squared plus bx plus c equals 0 is a quadratic equation. How about ax squared plus bx equals 0? Yes, it is also a quadratic equation. And this equation is an example of incomplete quadratic. Why? Because the value of c is missing. How about equation number 3? Correct. It is also a quadratic equation. And this equation is also an incomplete quadratic. Why? Because the value of b is missing. Now, the topic is all about quadratic equation by extracting square root. The question is it applicable to equation number 1? Or is it applicable to equation number 2? Or is it applicable to equation number 3? The answer is, it is applicable to equation number 3. Now, how are we going to solve ax squared plus c equals 0 by extracting square root? The answer is, the first step is, you need to isolate the quadratic term on one side of the equation. See to it that the value of a equals 1. If the value of a is not equal to 1, you need to divide both sides by the same value of a so that the value of a become 1. If the value of a become 1, then the equation is in the form of x squared equals k. Now, you may observe now in the equation x squared equals k, the value of a equals 1. The quadratic term was already isolated. So the next step is, get the square root of both sides, meaning you need to determine what is the square root of x squared and what is the square root of k. And the answer is, the square root of x squared of course is x, the square root of k of course is positive negative square root of k. So what is the solution of the equation? X squared equals k. The answer is plus and minus square root of k. And this is also can be written as the solution of the quadratic equation x squared equals k is negative square root of k and positive square root of k, or is positive square root of k and negative square root of k. Let us now proceed to the example. Solve each equation and write your answer in simplest form. Let us start from equation number 1. Z squared equals 49. The first step is, you need to isolate the quadratic term on one side of the equation. But in example number 1, the quadratic term was already isolated. So the next step is, you need to check the value of a. So the value of a must be equal to 1. Now in example number 1, the value of a equals 1. So meaning, we can proceed now to the next step, and that is take the square root of both sides. What is the square root of z squared? And what is the square root of 49? I think you are familiar about the square root, the word square root, the word radical. Now what is the square root of z squared? So the answer is z. And what is the square root of 49? Every time we take now the square root of a number, so there is one positive and there is also a negative number. So the answer now is 7. So what are the solution of the equation z squared equals 49? So the answer is plus and minus 7. Let us now proceed to example number 2. X squared equals negative 169. So the same in example number 1. You need to isolate the quadratic term. But in example number 2, the quadratic term was already isolated. So meaning, you're going to proceed to the next step. Take the square root of x squared and negative 169. Now, you may observe now that in number 2, it is different from number 1. Why? In number 1, it is a perfect number, positive perfect square number. While in number 2, it is a negative square number. And negative 169, or the square root of negative 169, is an example of a non-real number. So the question is, what is the solution of the quadratic equation x squared equals negative 169? And the answer is, there is no real solution. Now how about in example number 3? Isolate the quadratic term on one side. Check the value of a equals 1. Now in example number 3, the quadratic term was already isolated. The value of a equals 1. So take the square root of both sides. Now in example number 3, if we're going to compare it to example number 1 and in example number 2, then you can say that the square root of 12 is greater than 0 but not a perfect square. So this is an example of irrational number. So what is the solution of the quadratic? So the square root of x, of course, is x. And the square root of 12 is the square root of 12. But because of the word simplest form, so meaning we're going to simplify now the square root of 12. Find the possible factor of 12, and that is 4 times 3. And what is the square root of 4? So the answer is 2 times the square root of 3. So what is the solution of the equation? So x equals plus and minus 2 square root of 3. Now let us now proceed to example number 4. 3x squared minus 8 equals 88. So let us now check the equation. So meaning, you're going to isolate the quadratic term on one side. So we're going to apply now addition property of equality. Add both sides by positive 8 so that we can remove now negative 8. Negative 8. Now, or simply transfer negative 8 to the right. So it becomes now 88 plus 8. So the answer is 3x squared equals 96. Now, check the value of a. The value of a equals 3. So meaning, we need to divide each term by 3 so that the value of a become 1. So the equation now is x squared equals 32. Then, take the square root of both sides. So the answer is positive and negative 4 is square root of 2. Why it become plus and minus 4 square root of 2? Why? Because 32, there's a factor of 32 which is 16 and 2. And the square root of 16 is 4 and the square root of 2 is the square root of 2. So the answer now is plus and minus the square root of 2. How about if the equation is in the form of the quantity of ax plus b raised to second power equals k? Can we apply extracting square root to this equation? The answer is yes. Now you may observe that ax plus b is the base of the power of 2. So meaning the value of the first degree term is missing. So meaning we can also apply. Let us now proceed to example. Solve the quantity of p minus 4 raised to second power equals 3. So what is the value of a of this equation? Of course, it is the coefficient of the quadratic term, and that is equal to 1 because there is no indicated value on the left side of p minus 4. Now, isolate the quadratic term. Now in this example, the quadratic term was already isolated. So let us now proceed to step number 2. Take the square root of both sides. And once you get now the square root of the quantity of p minus 4 raised to second power, the answer is p minus 4. And there is a positive negative. Why? Because the square root of 3 equals positive and negative square root of 3. So that's why after we take the square root of both sides, it becomes now p minus 4 equals the square root of 3, and that is the square root of 3, and p minus 4 equals negative square root of 3. So this time, we're going to isolate now the value of p. So meaning, we're going to apply now addition property of equality, add both sides by positive 4, so that we can remove now negative 4, or simply transfer negative 4 to the right, so it becomes now p equals 4 plus square root of 3, and the other one, p equals 4 minus square root of 3. So what is the solution of the problem? So the solution is p equals 4 plus square root of 3, or p equals 4 minus square root of 3. So the solution is 4 plus and minus square root of 3. Let us now proceed to the next example. Solve the quantity of 5m plus 1 raised to second power equals 7. The same in the last example. We're going to check the value of a, and we're going to isolate the quadratic term on one side of the equation. Now in this equation, the value of a is 1. Why? Because there is no indicated number on the left side of the quantity of 5m plus 1. The quadratic term was already isolated, so meaning this time we're going to get now the square root of both sides. And what is the square root of the quantity of 5m plus 1 raised to second power and the square root of 7? Of course, the square root of 5m plus 1 raised to second power equals 5m plus 1, and the square root of 7 is plus and minus the square root of 7. So that's why the equation becomes 5m plus 1 equals square root of 7, or 5m plus 1 equals negative square root of 7. Now, we're going to determine the value of m. So, we're going to combine now positive 1 to the right, and that is by applying now subtraction property of equality, or simply transfer 1 to the right. Okay? So it becomes 5m plus 1 minus 1 equals square root of 7 minus 1, or 5m plus 1 minus 1 equals negative square root of 7 minus 1. The reason why is to cancel or to eliminate 1 to the left. Now, the resulting equation becomes now 5m equals the square root of 7 minus 1, or 5m equals negative square root of 7 minus 1. So the value of a equals 5, not equal to 1. So that's why we're going to divide now each term, or both sides of the equation, by 5, so that the value of a become 1. And the final answer now is m equals negative 1 plus the square root of 7 over 5, or m equals negative 1 minus square root of 7 over 5, and the solution of the quadratic equation is negative 1 plus and minus square root of 7 over 5. And this is an example of irrational solution. So let us now proceed to the next example. Solve the quantity of 7z plus 1 raised to second power equals negative 1. So the same in the last example 1 and 2. Check the value of a, isolate the quadratic term. Now in this example, the value of a equals 1. The quadratic term was already isolated, so determine the square root of both sides, or get the square root of both sides. Now, what is the square root of the quantity of 7z plus 1 raised to second power? Of course, the answer is 7z plus 1. But how about the square root of negative 1? The answer is the square root of negative 1. But the square root of negative 1 is an example of non-real number. So what do you think the solution of this equation? So we have now 7z plus 1 equals the square root of negative 1, or 7z plus 1 equals negative square root of negative 1. But because the square root of negative 1 is non-real number, so meaning there is no real solution. So after we discuss about the different example on how to use extracting the square root to solve the given equation, so this time it is your time to solve equation 1 and equation 2. Equation number 1, x squared equals 121. And equation number 2, 4x squared minus 3 equals 9. Your time start now. Time is up. Check your answer. In equation number 1, x squared equals 121. Let us now check your answer. So the solution, the square root of x squared equals square root of 1. So the final answer, x equals 1 and x equals negative 1, or the solution is plus and minus 1. And for your number 2, 4x squared minus 3 equals 9. Check your solution. So the answer is plus and minus is square root of 3. So that is after you get the square root of x squared and the square root of 3. Let us now proceed to the next activity. Solve the given quadratic equation by extracting square root. So we have now 5 exercises. Equation 1, x squared equals 16. Equation 2, 2x squared equals 50. Equation 3, r squared minus 100 equals 0. Equation number 4, the quantity of x minus 4 raised to second power equals 169. And equation number 5, the quantity of 2s minus 1 raised to second power equals 225. I will give you now a couple of minutes or a couple of seconds to solve this problem. Okay, your time start now. Time is up. Check your answer. In number 1, the answer is plus and minus 4. In number 2, x equals plus and minus 5. In number 3, the solution is positive and negative 10. In number 4, x equals 17 and the other one is negative 9. In number 5, the value of s is 8 and the other one is negative 7. That's all. Thank you very much for watching. God bless everyone. And again, I'm your teacher, Maestro Neo.